Okay, ladies and gentlemen, so now we will move into the second part of this pre-algebra tutorial. And in this second part, we are going to be learning all about and working with circles. Okay, so circles, very important. Um, a great tool to have when you're working with circles is a compass, but we don't need that for this assignment because the assignment itself provides the circles, but that is a tool that we will learn to use definitely before the end of the year. All right, well, let's get into it and clear the work surface. The first problem asks us to find the diameter of the circle. So we are given half the diameter, we're given the radius, and the radius of a circle, the radius of a circle is equal to 1/2 of the diameter. 1/2 of the diameter. And what that means in practice is that you can just take the radius and multiply by 2. 2r. Okay, 2 times r. So 2 times r diameter equals 2 times r. Therefore, okay, now I'm going to write a symbol up here. So if diameter equals 2 times r, then okay, or therefore, diameter equals 2 times r, therefore, and then I put these 3 little dots. And those 3 little dots mean therefore. So it's like you're making a sentence, you're stating something. So diameter equals 2 times the radius. Therefore, the diameter equals 2 times 11, which equals 22. Okay? And get our little ruler back, 22 kilometers. Don't forget your units. So 22 kilometers. And that's number 9. Okay, number 10. Right? Remember, diameter equals 2 times the radius. And I want to see that. I mean, it's trivial, but I want to see it. Diameter equals 2 times the radius. Therefore, the diameter equals 2 times 10, because 10 is the radius. Okay, you might want to label these. 10 is the radius, so 2 times 10 equals 20. 20 what? 20 feet. Okay, so 20 feet is the diameter. Okay, easy enough. The next problems give us the diameter, and they ask us to find the radius. So now we can actually manipulate our previous little equation and come up with the equation of a radius. Let me show what I mean. So here's like a little statement. Let's write it out in English. If diameter equals 2 times radius, okay? Now, so that's our conjecture. If the diameter equals 2 times the radius, what is the radius? Okay? Now, if you know this off the top of your head, that's one thing. But actually solving for the radius is another thing. Now, this is getting into a little bit of math here, but if I want to, right now I've got radius almost by itself, but if I want it to be totally alone, I have to get rid of this 2 that's currently being multiplied by the radius. So I would look and see what is currently happening. 2 is currently being multiplied by the radius. If I want to get rid of the 2, I've got to do the opposite of whatever that operation is. So it's currently being multiplied, therefore I will divide. So in order to keep the equation in balance, remember, you must balance your equation. I'll divide the right side by 2. Okay, to get rid of that 2, I've got to divide by 2. But in order to keep the equation in balance, I have to divide the left side, okay, whatever's on the left, which currently is just diameter, by 2 as well. Okay, to keep it in balance, I've got to do the same thing that I do on one side on the other every time in algebra. Okay, now here's a concept we've got to get comfortable with, and that concept is called canceling. So because I've got a 2 in the numerator and the denominator on the right, they can be canceled out because 2 divided by 2 is 1. Just as, it cancels out. And what's left behind, this is something I really want to highlight. What's left behind are 2 of these little 1s. The thing is, we just don't write them, okay? So now, just keep working here. Now I've got diameter, which I'm going to represent just by the D for simplicity. I now have diameter over 2, diameter divided by 2 is equal to, and then I'll simplify writing radius and just write r. So now I've got diameter divided by 2 equals r, okay? Now what's another way that I can write d over 2? Okay, so right now it's saying d divided by 2. That's what it's saying. But I could write, so just a little side work here, d divided by 2 is equal to 1/2 times d. Now, this is something else we'll practice a lot, but what I'm doing is I'm recognizing that there's actually a 1 in the numerator, okay, and it's being multiplied by d. So it's possible for me to rewrite this equation as 1/2 times d equals r. Now, this might seem like a lot of nonsense given that we know the answer is 5. Just by looking at that, I know that 10 divided by 2 is 5. But the math to arrive at the formula is actually maybe for some people not all that simple to understand. So those orange ones that I wrote, just based on my experience teaching this class last year, it wasn't always clear that those ones were there. And so for the time being, I'm going to spend a lot of extra time making sure you remember there's ones there because they become important later. We just don't write them. So instead of writing 1 times d over 2, this time on the left, I did want to keep that 1. And so I wrote it 1/2 times the diameter. But on the right side, it didn't really help me at all understand the problem to multiply 1 times the radius divided by 1. 1 times r over 1 is just a complicated way of saying r. See what I mean here? I've got 1r, okay, 1r over 1. Okay, certainly a true statement, but that is just equal to r. Okay. The key thing to remember is when I canceled the 2's, I didn't leave behind zeros or what people say nothing. I didn't leave behind nothing. I left behind a 1. And so that's a point I'm going to make very clearly over and over again until it's just part of your understanding of mathematics. There's always a 1 left behind when you divide something out like that. Okay, so now we've got our formula for the radius of a circle, and that radius is 1/2 the diameter. So again, we could write radius is equal to 1/2 the diameter. So 1/2 d. Okay, therefore, got our 3 little dots. Therefore, radius equals 1/2, put open parentheses because you're going to stick a number in for the diameter, 1/2 times 10. Okay, and 1/2 times 10 is equal to, remember, we can write, so let's write 1/2, multiply. Now, remember, we can write 10 as 10 over 1. So 1/2 times 10 over 1, right? That way we never forget that 10 can be written as a fraction with 1 in the denominator. Okay, so multiply across. 1 times 10 is 10. 2 times 1 is 2. 10 over 2. Now, this is not the most reduced form of the fraction. What I do to reduce this fraction is I find the greatest common factor. Okay, so when I find the greatest common factor, I'll take 10 and 2, and I'll find the greatest common factor. Well, 10 is 2 times 5, and 2 is, well, I guess 1 times 2, right? So the greatest common factor is 2, and that's what I'm going to divide 10 and 2 by. I'll divide 10 and 2 both by the greatest common factor they share, which is 2. And that gives me 10 divided by 2 is 5, 2 divided by 2 is 1, and I'm given 5 over 1. And we know, based on this, that if we see a whole number over 1 as a fraction, we can rewrite that as a whole number. So, long way around to make a point. Now, everybody watching this video, I know that you knew that the radius of this circle was 5 inches. Okay, I knew that. That wasn't the point. The point is, can you take a formula and rearrange the terms and then solve that new formula that you created? So I think you'll all agree that this was an extremely complicated way of doing something that you're really quick to do in your head. But in algebra, we kind of unpack that stuff that we learn how to do real quick in our head. And instead of just using what we know, 10 divided by 2 is 5, done, move on, we have to think more about it on a symbolic level. Okay, so there was a method to the madness. There was a purpose in this. But in the end, you'll come up with the same thing. Okay, for number 12, we won't go through so much of the behind the scenes work. We have a diameter of 12. So another thing we like to do in algebra is write down what we're given. So in this problem, what are we given? We are given that the diameter equals 12 inches. Okay, now recall, okay? Recall what? Recall that the radius of a circle is equal to 1/2 of the circle's diameter. And we know that because we derive that down here. Okay? So the radius equals 1/2 the circles of the 1/2 the diameter of the circle. Therefore, okay, you see those 3 little dots, that just, it's a symbol for the word therefore, so I don't have to write it out. Just so you remember. These 3 dots, they come in handy. They mean therefore. Okay, so therefore, r equals 1 times d. Therefore, our radius equals 1/2 times whatever the diameter is, 12. 12. Okay, now recall that we can rewrite that as 1/2 times 12 over 1. I just multiply across now. 12 times 1 is 12. And 2 times 1 is 2. Now again, we have to reduce the fraction. So remember to reduce. You have to reduce. Now in this problem, it's really obvious how to reduce. But in other problems, it won't be obvious. So I'm going to go ahead and show how to find the greatest common factor. The greatest common factor of 12 and 2. And the way you do it is you say, well, what's 2 times 6 is 12, and you can break 6 down into 2 times 3. And then greatest common factor of 2, we got 1 times 2. 2 is a prime number, so its factors only include 1 and itself. So here are all of the factors of 12, 2, 2, and 3. 2 times 2 is 4, 4 times 3 is 12. And the factors of 2, I just circle the thing that I have in common, okay, the greatest common factor. And we'll work so much more with this in the future. But what that means is I'm going to reduce my fraction by dividing both the numerator and the denominator by 2. So I'm going to divide, let's see, equals 12 over 2. And then I will divide the numerator by 2 and the denominator by 2. And this is going to equal 6 over 1. Which we know is just 6. 6 what? 6 inches. Okay, we can write inches as a little close quote symbol. It's not coming up there very well. 6 inches, right? So that's 6 inches. So we found our two radii, 5 and 6. Okay, moving on. Now we want to know the circumference of the circle given the radius. Okay, so here's now you're starting to understand why we definitely want to think carefully about our formulas when we're computing these circumferences and areas. Now this right here, round your answer to the nearest tenth, we're gonna junk that. Right, I'm going to junk this instruction. I don't want you to use this approximation. Instead, we will leave pi. We will leave pi equal to just the symbol pi. So that's called exact. Okay, this is an exact representation of what is an irrational number that goes on forever and never ever repeats. So any attempt to turn pi into 3.14, 3.14159, whatever, you just keep going and going. You'll never get all the numbers, and so it will always just be an approximation. And that's why they said round to the nearest tenth, but we're going to keep it exact. Okay, we'll just leave pi as a symbol. And here's what I mean by that. How do you find the circumference of a circle? Well, here's how you do it. You take the circumference, let's see, the circumference, let's write it out, circumference. The circumference of a circle is equal to pi times the diameter. Okay, that's one way to look at it. Pi times the diameter. Well, we're not given the diameter, we're given the radius. We know from our previous problem that the radius is equal to 1/2 the diameter. Okay, so I could also say the circumference is equal to, now think about this for a minute. The radius is 1/2 the diameter. Okay, so I'm given the radius. And I want to find the diameter. Okay, so the circumference is equal to 2 times the radius times pi. Now let's walk through that real quick. So remember, the radius equals 1 half times the diameter. Okay? The radius equals 1/2 the diameter. So if I want to find the diameter, I have to multiply, I have to get rid of this fraction on the right. I've got 1/2 over here. So this is important. I can rewrite the right side of this equation as 1 times the diameter over 2. Okay, and that's equal to the radius. Right now, if that wasn't obvious, it's because I'm multiplying the fraction 1/2 times this whole number diameter, and so the fraction bar just kind of extends out underneath the word diameter. So 1/2 times the diameter is equal to 1 times the diameter over 2. Now, if I want to get rid of this 2 in the denominator, I multiply both sides by 2. Because I'm currently dividing the right side by 2, I've got to do the opposite, which is to multiply both sides by 2. And it's helpful sometimes to write 2 in its fraction form. So we'll write 2 in its fraction form. That way we understand what we're doing. You can kind of look at it this way. The 2's now cancel out on the right. And on the left, I'm left with 2 times the radius equals to the diameter. Because 1 times the diameter over 1, we can just write it as the diameter. So now I've got my diameter as 2 times the radius. So wherever I see diameter, okay, I can just stick this new little formula. Well, up here I see pi times the diameter. So because I see pi times the diameter, right, I can rewrite that as pi. So this is circumference. We'll just write C. Circumference equals pi times, open parentheses, and then we'll put in 2 times the radius. 2 times the radius. Now again, many of you already knew that the circumference of a circle, okay, the circumference of a circle was equal to 2 times pi times r, right? And we could write this as 2 times r times pi, or r times 2 times pi, but most commonly this formula is written 2 pi r. And you've probably memorized it that way. But knowing how to get there when you're given something like the radius, and if all you can remember is pi times the diameter, then it's useful to know how to move between these two formulas, 2 pi r and pi times the diameter. You now know how to move from one formula to the other. So now it's just a matter of plugging it in. So I've got C is equal to 2 times pi, and all I'm going to do is plug in the radius figure now. What's the radius figure? 5. Okay, so now we have to multiply together our whole numbers. Okay, remember we're going to leave pi all by itself. So I've got 2 times 5, which is 10, times pi, which I'll just write 10 pi. Remember, when you're multiplying two numbers together, 10 times pi, okay, you can just write it without the little dot. You can write 10 pi. Right, so the answer is 10 pi. And we're not going to approximate pi, so we'll just leave it as 10 pi. Okay, next problem, number 14. We are given a radius. So what are we given here? Let's write what we're given. We're given that r for radius equals 11 kilometers. Okay, I guess I forgot to put in here kilometers down here. Okay, we're given that the radius is 11 kilometers, and we know from our formula, okay, circumference equals 2 times pi times r, so we know that circumference is equal to 2 times pi times r. Okay, therefore, the circumference is equal to 2 times pi times 11. Again, we combine by multiplying, find the product of those two whole numbers. Okay, 2 times 11, that's 22. And then we're just going to leave pi by itself. So the circumference is equal to 22 pi. And we're not going to approximate pi out to any decimals. We're just going to leave it as an exact value right there. That's called a constant. We're going to leave that as an exact value, just as the pi symbol. Okay. Moving on to area. Okay, so the area of a triangle, we got to know this formula. The area of a triangle, or I keep saying triangle, the area of a circle, the area of a circle is equal to pi times the radius squared, pi r squared. So what we do is we find the radius, we square it, and we multiply that by pi. And in this case, we're going to leave pi as pi. We're not going to expand it out. So basically, we just have to square the radius. So given r equals 9 centimeters, okay, given that r equals 9 centimeters, guess I forgot up here to put in kilometers. Keep forgetting to write my units. Given that r equals 9 centimeters, then, therefore, the area equals pi, and then we'll put an open parentheses, 9, okay, and then we will close the parentheses and put squared. So now this is my work I've got to do. The area is equal to pi times r squared, pi times 9 squared, and so that's pi times 9 squared. Now 9 squared is just 9 times 9, and 9 times 9 is 81. So I've got pi times 81. And a cleaner way to write that is just to write 81 pi. We tend to put the pi symbol after the whole number, and then it's centimeters. Okay, 81 pi centimeters is the area of that circle. Again, we're not evaluating pi out to any numbers. We just leave it as pi. Okay, on to number 16. This one's going to be a little interesting because it's a decimal. So again, number 16, what are we given? We are given that r equals 5.5 kilometers. Okay, that's what we're given. And what we want to know is the area. The area, okay, you always want to write this out. Area is equal to pi times the radius squared. Therefore, okay, therefore, the area is equal to pi times, open parentheses, we're going to put in 5.5 for r. 5.5, close parentheses, squared. And so what it basically telling us we got to do is we have to multiply 5.5 times 5.5. So it's a little multiplication problem we got to do. And we're going to do it without a calculator. So 5 times 5 is 25. Okay, carry the 2. 5 times 5 is 25, 26, 27. Okay, 5 times 5 is 25. Carry the 2. 5 times 5, 25, 26, 27. Right? This is the multiplication algorithm. Then we stack add. We got 5. 7 plus 5 is 12. Carry the 1. 2 plus 7 is 9. Plus 1 is 10. Carry the 1. And then 3. 3025. I have these decimal points here, so there's 2 of them, therefore 5.5 times 5.5 is 30 point. Now look, here's what you got to do. You got to count up how many spaces you got after your decimal places. Here I've got 1, and here I've got 1. So I'm going to move over 1 plus 1 space, 2 spaces. 1, 2. There, 30.25. So the area is equal to 30.25 times pi. And again, we are not going to pi kilometers, okay. We're not going to approximate pi, so we just leave it like it is. Okay. Now for this assignment, for this video, you do number 17 and you do number 18. Okay, so you write down what you're given and you write down the formula for the area and you think about this, because in this problem you're not given the radius, you're given the diameter in these two problems. So I want to see you go from diameter to radius and then plug that into your formula for the area of a circle. Okay, so you do number 17 and 18 and send me the answers on Remind.